and welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Wayne Raney.
Thanks, William. Hey, everyone. I'd like to thank you for joining me in this fourth part of a six-part series. We'll be covering the ideal cleaning process when it comes to vapor degreasing. Here's some previous and future topics covered in this vapor degreasing series. Be sure to look these up on Kaiser's website and check them out. Today, we're going to be covering the ideal cleaning process. There's several ways that you can enhance your cleaning of your parts, but here we'll be talking about the basics, including the anatomy of a degreaser, all the way to the do's and don'ts when it comes to your process. Here's a typical vapor degreaser diagram. The reflux, as it's called, is the vapor product is boiled in a boil sump. The vapors rise and condense on your coils, refrigeration coils. The fluid drains into your water separator, separates out the water, and cascades the chemistry back into the rinse sump. This then cascades into the boil sump. Think of this as the part enters the vapors, its temperature is above the vapor temperature. Thus, the vapors condense on the parts, which has oils and greases on it. This condensation action is how it degreases in the vapor zone. Here's a couple different examples of different sizes of large and small vapor degreasers. The next slide, here's a picture of the inside of a vapor degreaser. Almost all degreasers have a primary refrigeration coil and freeboard or upper coils. In an ideal process, the primary or the lower coils are kept around 32 Fahrenheit on contact, and the upper coils of the freeboards remain about 0 to -20 Fahrenheit. The primary coils are used to keep the vapors in the machine, and the freeboard coils are used to keep the moisture from the outside air from entering the solvent tanks. Here you can see the boil sump, rinse sump, and the water separator. In a normal process, you'll see that all the contaminants concentrate up in the boil sump, which gets dirty. Then the vapors condense on the coils, or return solvent to the water separator, which cascades in the rinse, then the boil sump. The next session is going to be all about cleaning up the boil sump in real time. So be sure to check that out. So the parts enter the vapor zone. They lower into the vapor zone. The parts are heated up to the vapor temperature. Once the condensation action, which is what cleans the part, once the condensation action stops, you lower the part into the boil sump. It then exits, comes into the rinse sump, which the temperature decreases over time, and then it enters back into the vapor zone. The parts then condense again because the parts are cooler than the vapor zone. This condensation action provides the final rinsing action. And then the parts rise up through the freeboard zone and out your degreaser. There are certain elements or regulations that you have to abide by when talking about a vapor degreaser. NESHAP is the National Emission Standards for Hazardous Air Pollutants. When talking ideal process, you have to abide by these rules, among which are such as air drafts, part speed, freeboard ratio, temperatures, and basket sizes. The average airspeed across the top of the degreaser must be less than 50 feet per minute as measured by a velometer. So you take the airspeed on all four corners, and you don't want the drafts on the top of the degreaser because it'll pull the solvent out and get into the atmosphere. So the average has to be less than 50 feet per minute. Another of the NESHAP rules is the material handling speed. The basket speed going into and out of the degreaser must be no greater than 11 feet per minute. You can measure this distance over time and adjust your speed based on this measurement. Another NESHAP regulation is freeboard ratio. When talking freeboard, the ratio of the freeboard height to width must be at a ratio greater than 1.0. For example, you take your width, your length, the height from the vapor line up to the top of the machine. Once you got those measurements, you take your freeboard height divided by width, and it must be at a ratio greater than 1.0. In this case, it's 18 inches divided by 12, so 1.5, we're good to go. If you have trouble finding the vapor line in your machine, here's an example of a little video where it shows the dripping on the coils. So you can see it dripping on lower coils, but not on these upper coils up here. The height that you would measure from is where the dripping stops. So that upper coil right there. You should then check your refrigeration temperatures if there is a problem, if your vapor line is climbing higher than that. There's also a NESHAP requirement for this temperature, for the refrigeration temperature. The rule states that in an idle degreaser, this temperature must be below 30% of your boiling temperature. So you take your temperature measurement in an idle machine, in this case is 31. 35 Fahrenheit is 30% of this solvent's boiling point. So 31 is less than 35, so we're good to go there. The last NESHAP regulation we'll be talking about is parts basket size. The basic rule is you don't want the basket taking up more than 50% of the solvent-air interface, or else there's a possibility of a hydraulic effect. The parts will displace this interface so much that the solvent is basically forced out of the machine. We touched a little bit about the NESHAP rules and guidelines, but one last thing to touch on in the ideal cleaning process is you want to make sure that your thermostats are set properly. Here's an example of the thermostats on our particular machine. This one has the refrigeration temperature, vapor up, solvent vapor control, and high temp cutout. The refrigeration temperature is to ensure that you have proper cooling. The vapor up is so that you can go in auto mode. The solvent vapor control is another safety so that your vapor blanket doesn't get too high. And the high temp cutout is for the boil sump temperature. This helps determine when your boil sump needs to be cleaned up. So since we spoke about the thermostats, you want to talk about refrigeration temperatures. We touched on it, and you want your primaries to be about 32 and your freeboard to be about 0 to negative 20. The primary coil is what keeps the solvent in the tank, and the freeboard keeps the moisture out of your solvent by way of the water separator. When talking an ideal process, there are some do's and don'ts. So I'll show you some short videos of an ideal and not so ideal process. Here's a typical large size vapor degreaser with an oversized hoist. Here's a short video that you can see there are several issues going on. First, they manually lower the basket into the tank, which allows them to exceed the 11 feet per minute. You can see the ice on the freeboard coils, and so there's no way that they're getting less than 32 Fahrenheit. You want your freeboard coils to be 0 to negative 20. Again, even though they're using this basket for a cleaning evaluation and not a typical process, the part speed should not exceed the NESHAP speed. So when they're raising and lowering the parts basket sequentially, they're actually creating a hydraulic effect, even though the parts basket doesn't take up more than 50% of the solvent air interface. Here you can see the icing on the freeboard coils and then moving the parts up and down before they settle into the rinse sump. Now, with that said, the parts did come out clean and shiny and also dry, but it wasn't the ideal cleaning evaluation because it doesn't reflect real world conditions. Here's another short video showing how this lid opens, and I like how it opens because it keeps the vapors from escaping. You turn the boil heat on, and you can see the boil sump start to boil. In this case, it's on the right, and the rinse sump is on the left. The machine has a superheat, and it also has sonics in the rinse. So they turn on the sonics, and you can see the sonics come on right here. And then they'll show the coils next. On the coils, notice the dripping on these coils. These are actually the upper coils. And so their actual vapor blanket is too high. The oils on these parts will come off, but notice here on this next slide, you'll see the vapor is condensing on the upper coils. It means that your vapor level is too high. So you don't meet your NESHAP rule of a freeboard ratio of 1.5. Again, this is another cleaning evaluation. The machine doesn't have an automatic hoist, but the operator should pay attention to the speed of the parts and ensure that they don't lower the hands into the vapor zone. So in the last video, the vapor level is too high, but in this video, it demonstrates a proper vapor level. So when we're talking about proper freeboard ratio and the vapor blanket, In this video, you can actually see the vapor line on this piece of sheet metal. So most of the time you could go by the dripping of the coils, or you could see the vapor line on the side of the tank walls. Here's an example of a proper and improper orientation of the parts. You want to make sure that there's proper drainage when pulling the parts out. Here, the operator is cleaning metal cups. And when you rack your parts, you just want to make sure that you have the proper solvent drainage so you're not pulling out solvent. If your machine has a spray wand, then you want to make sure that you keep the spray underneath the vapor level to keep the operator safe from any vapors and to keep the vapors from escaping the machine. So we talked about some don'ts, and last we'll end on a good note. So the parts are lowered into the vapor zone. Once the condensation action stops, the parts are lowered into the rinse sump and the sonics are started. Once the sonics are done, then a part is raised below that 11 feet per minute NESHAP rule and regulation, and it's raised into the vapor zone where the drying takes place. Here, the video speed is increased because it takes a while for the part to get up to temperature and fully dry. The part is raised through the vapor zone, comes out of the machine, and then your part is clean and dry. And your part should be around the same temperature as your vapor zone. This concludes our short tech-to-tech session on the ideal vapor degreasing process. And here's some more highlights of this presentation. Next, we'll move on to some frequently asked questions. Usually, some people ask, how do I know if my vapor degreasing chemistry falls under the NESHAP guidelines? There are the usual suspects, such as trichloro, perc, methylene chloride, and transdichloroethylene. Those are some that fall under the NESHAP guidelines. But you should be able to find a list of these materials on the EPA.gov government website. Another person asked, how do you know what the acceptable permissible exposure level is for this chemistry? The PEL is found in either the data sheet or the material safety data sheet. And another person asked, how do I know what temperatures to base my thermostat temperatures on? Well, you base it on the boil point of the solvent. And for example, the solvent vapor control, or SVC, in our example on this presentation is set to 106. And if your boiling point is 116, then the solvent vapor control is 10 degrees below. If your vapors get too high, then the temperature will reach 106 and it'll trip off your boil heat. This is to protect your operators and the environment so nothing is lost. Another question is, what if my vapor line is too high in my machine? You should periodically check your refrigeration temperatures to make sure that your system is operating at peak performance. So you take the surface temperature of both the primary and freeboard coils. So I'd like to thank you for checking out our part 4 of our 6-part series on vapor degreasing. Be sure to check out these other topics in upcoming sessions. And now I'll turn it back over to William.
Thank you, Wayne, and thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KaiZen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? The answer is yes. Just go to tech2tech.kaizen.com and fill out that subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.